So basically what we're going to start off today is we're going to talk about HighScore demo. This is going to be for phase identification. Okay, so this is after you do analysis and you can use the data coming from the Rigaku or the Empyrean for this. So here's the couple of steps. The one most important step is to be consistent. So whatever processing you do, and you can go ahead when you first start looking at your data, do a bunch of changes and see what works best for you. But after that, after you settled on a couple of steps, just be consistent, particularly if you're going to be starting to compare data across each other. So the very first step is we're going to determine the background, and you can either do that automatically or manually. It's a preference, you know, it's up to you. Smoothing. Some people say that they don't like to smooth the data at all. I do it sometimes if I get noisy data. The one thing that I'll notice between a smooth data and non-smooth data is that you typically get better peak fitting with the smooth data. After everything's smooth, then we're going to go ahead and actually find the peaks. We'll do an automatic search for the peaks. Sometimes it doesn't work. It will pick up most of the major peaks. Some of the smaller minor peaks or peaks that overlap, you may have to add in manually. So I'll show you how to do that. Then we're going to go through a peak fitting solution after we find the peaks and we've added all the ones that we think are there. And then we'll do our search match, and then finally go to identify the phases from that search match. Okay. So the one thing you want to do is determine the background, and you can see from the graph on the right, this is part of a diffraction pattern. So the background that's fitted is that green line at the bottom. I think you can see it here. So if you look at these peaks, this little small green peak here, we're comparing the peak intensities. We're looking at the area under the peak. And in this case, that peak is very small. The background part is that red rectangle underneath it. And you can see that that actually is greater than the area of the peak. So that's going to really throw off our relative intensities compared to something, a very large peak up at a higher angle where you have lower background. So we want to make sure that we fit that background well, because part of the identification is using that peak intensity. There's a couple of ways to do this. A lot of times I will just do it manually. And basically you have a certain number of points set up on the background and you just move them. You can add more points. You can just move the points. You can take off points. The biggest thing is to just do it consistently. And you can see that here on this graph. We have all these points that you can move. And what I like to do, so if you notice this, the background usually starts high up at the low end, and then it should tail off and get gradually flat by the end of at higher angles. And if you notice here at the far end, that peak is actually elevated, or that background point is actually elevated. So what I'll do is drag that down. I'll probably add a peak here in between and bring this down so this is more of a curve. But you don't go crazy adding a lot of points to this, a lot of peaks to the background. The other way to do this is automatically. And basically, it's just a matter of how many points between the data, or how many data points you want to do. Like granularity is basically, I'm going to use 55, or every 55 points, I'm going to average that out. And then a bending factor is basically how much it's going to allow that to bend into the peaks. So you can see, you can get some very crazy stuff. Typically, if I'm going to do an automatic, I will do a very large granularity and followed by a very small bending factor, right? Because this one's a low granularity, high bending factor. You see that the peak, that the background is going up into the peaks, and that's not what we want. We want it to match what the background should be. So let me get out of here for a second, and we'll actually start up HighScore Plus. All right, so here is the data that I loaded. Basically, I went File, Open, found it. And you can see that the Rigaku will give you several data files. The one you want is the raw file, okay? So here's my data right here. The first thing I want to do is go ahead and do the background, okay? So I'm going to do right click and determine background, okay? So you can see here, if I do the granularity, like let's do a very low, high or low granularity, you see how it bends up? Let me zoom up a little bit on that. Okay, so you see how that's a very poor fit for the background, okay? So typically if I'm gonna do it by automatic, I'm gonna go to a fairly high granularity. And then my bending factor, if I do this very high, you see again, it goes kind of crazy. I will leave this fairly low, almost at 0 sometimes. And that's actually pretty good, okay? So once that's done, you accept it, okay? You can subtract it out. I tend to not subtract it out. I usually just hit the accept and then it'll give me the background on there. Another way to do this is manually. So you can see that this point here is a little bit elevated. I'll actually come in here and I'll drag this down a little bit. I know that it's supposed to be fairly flat. It should be high at the bottom here and then it'll flatten out. See how this point here is way above these peaks here? You want to bring that down. You want to make this as level as possible, just a gradual kind of. And if I want to, I can add another point if I need to put a point in there and move that. I can also delete it if I want to, if it makes it easier, okay? But once that's done, I go ahead and I accept that background, okay? So now you can't see it because the peaks are so high, but see that my background is actually drawn across the bottom there, okay? Okay. The next step, if you want to do this, it's up to you. A lot of times I won't do this, particularly with some pattern like this. It doesn't look like it's noisy at all, but it's very, very intense, very sharp line. So I wouldn't worry about it, but you can, if you want to, do a smoothing, okay? Again, don't go crazy. Don't do like anything like 42 or something like that. Something like that is going to be just way out of there. Most of the time, I will not do a smoothing any greater than 3 points. Okay, and a lot of times, like I said, I won't do a smoothing. Usually, the first time around, I won't smooth. I'll actually just process as is. And then if I have issues getting smaller peaks to show up, or if I have a really poor fitting, then that's when I'll go ahead and go back and do a smoothing. So I'm not going to smooth right now. I'm just going to go ahead and close. So now the next thing to do is we're going to find our peaks. Okay, we've got our background subtracted. We've got pretty good peaks here. So we're going to search for our peaks. This is the typical search parameter. Okay, the default that's on here, I would pretty much just leave that as is. You can play around. I really am not too sure about what some of these changes will do. All I can say is that it actually comes up pretty well. So I'll search the peaks and you can see that it picked up most of these peaks here, right? Let's see, let's go right around here. So you see this light brown, this light blue background? That's what it's saying is a peak. If you like what it says, we'll go ahead and we'll just accept, okay? So one thing to note is you can see that it's got most of the peaks, but it doesn't have all of them. So now this is where you have to come in and actually start to do a little bit of a addition by yourself. The other thing I'm gonna look at here is I'm gonna look at the difference plot, okay? So this plot here is a difference between the blue line, which is its calculated peak, and then also the red, which is the real data. Okay, so the first thing I'm gonna do is I'm just gonna zoom in kind of on these lower level peaks. And I can see that there's some that I think are there. So one, you can just right click and we're going to insert peaks or Control R. And wherever you think there should be a peak, just go ahead and put one in for now, And don't worry about it the way it looks or anything like that. We'll worry about that later. So it looks like there's one there. And I think that's most of them. Yeah, there might be one right in here, but I'll hold off on that one. So I'll take that off. Okay, so now I'm going to zoom out. Okay, so I'm going to basically now perform the peak fitting. Okay, so I'm going to go to Analysis, Fitting, Start Fit, and we're going to do a default profile. Okay. So again, look at the, what you want to do is look at this graph at the bottom here, which shows the difference. We're going to start fit, default profile fit. Okay, so you see it got pretty good. Okay, so it got better than it was before. These peaks are really sharp, and sometimes it has a really hard time getting a good fit with these peaks if they're really, really sharp. But you can take a quick look to see how they're fitting around there, and it's not bad. The other thing I will say is you may have to run this more than one time. Okay, so sometimes I think there's a default that only does so many iterations, but we have this value here about 13.13. If I go ahead and run it again, we'll see if it actually gets a little bit smaller. Okay, so it got a little bit smaller, and that's actually pretty good. So I think it found most of the peaks. Most of the differences you're seeing are kind of like in this really, really high peaks that we have here. There's probably, let me see what's here. There may be 2 peaks here, but I'm not going to worry about that for now. Okay. So the next step is let's do our search match. Okay. So I'm going to right click and we're going to do a search match. Okay. And let's go ahead and edit restrictions. Okay, so right now I don't have any restrictions as far as elements. So right now, if you look down here, we're going to look through all these patterns here. So it's the computer. It's not going to take it very long, but if we want, we can just go ahead and search through all those. We can say that I want a minimum number of 1 element in the outcome, or if I know if it's going to be a multi-element, I can say minimum 2. I know what this is going to be. It's aluminum oxide. So now if I say there's 2, it'll actually reduce that a little bit, or should go a little bit quicker. Quality, we're not going to worry about quality right now, but I will go over that a little bit later. But you can also say that you want just certain high quality patterns as opposed to other ones that may or may not be of a good quality. You also want to, if you know that your phase or your material was not at room temperature, you can skip the non-ambient ones. So if you click that, you can see that this number went down a little bit. Like I said, we're just going to go ahead and we don't have any restrictions on here right now. We're just going to go through everything. So we'll say close. And we're just going to go ahead and do a search. Okay, let's go back here. Okay. So now it's come up with a lot of stuff over here, right? So we'll hit OK. And what you want to look at, this is the score factor, okay? Typically, the higher the score, the better. Oh, why is this up here? Let's remove that. Okay. Okay, sorry about that. So, what this is a score up here, okay? So typically the higher the score, the better. And that's what you're seeing here. Basically, it's all coming up as aluminum oxide, but notice that there's a lot of different aluminum oxides here. So one of the things that we're gonna do is we're going to take a look at, and this is one of the things that doesn't come up all the time, this object inspector pane, okay? So one of the things you want to look at when you're looking at all these is take a look at what it's telling you over here. Okay. Basically, it can tell you, so this is a blank marked as deleted by ICDD. So this is where the quality comes in. And then this is where you're also seeing, like, you know, this is alpha aluminum oxide. What other information that you're going to see here is the crystal structure, the quality, sample color. So obviously if you run a sample and you know what color it is, and most of you are not going to have a total unknown. Most of you know what you're trying to get. You probably know your starting materials and you know what possible phases can come up. So now let's go ahead and do some restrictions on the search again. So we're going to go back and we're going to search. So I've got way too many cards. I think there's like over 400 hits here. So we're going to go to edit. And I'm not going to worry about the chemistry right now because it's coming up with aluminum oxide, but I'm going to go with the quality. So the star quality, those are like your really good cards. And that means that it's a standard. It's been, you know, certified. It's really good. There's some patterns that are refined. There's some that are just indexed and some that are just calculated from software. Those are probably the top 4 best cards to look at. You can have blank also. This basically means that a blank rating on here is an old rating from ICDD, where it's basically, it's not any of these lower ones and it's not any of these higher ones. It's just considered regular. But right now I'm just going to go with these higher valued ones. And you can see I've cut down the number of patterns. So I'm going to go ahead and close this and I'm going to run this again. And now it should just come up with those. Okay. So again, it keeps putting aluminum oxide here. I don't know why it's doing that automatically. Let's just go ahead and remove that pattern. So it's the aluminum oxide again. And now if you notice, here's the very first one that shows up very high. It's the star rating. Now on this lower level here, you see where the peaks line up. Okay. And we actually have a pretty good lineup here. The other thing that we're going to look at here is we're going to look at this ML here is matched lines. Okay, so that means that it's matching up 15 lines. TL is the total lines in the card or the pattern that you brought up. So basically, of the 15 lines that are in that pattern, 15 are matching up. So that's a pretty good match. So that at that point, we can bring that up and match it. Okay. And now this is showing me where all my peaks are. And basically it's got most of them. There may be some smaller ones here, and I doubt that there's actually another phase in here, but it could be. But that's the way you do a very quick match. All right. Then that's the way that you do most everything. Okay. So that step-by-step process where basically you just do the background subtraction, smoothing if you want, then the peak search, peak fits, and then finally the match. Okay. Now, again, like I said, a lot of you guys are going to know exactly what is in your material. So if you want to, we can go to search again, and I can edit this and go to the chemistry. And I know that there's only going to be aluminum and oxygen in there. So that cuts down also on the patterns. I know my elements are going to be 2. So I'll close that, search. Okay. Now it's automatically taking this one, and I don't know why it's automatically putting it up in the pattern list. But typically you have to drag it up there. Now, a lot of times you don't usually get scores this high, but again, I'm looking at a standard here, so it's you know, not that big of a deal. So that's why I'm getting the high scores. A lot of times you will get scores like in the 50s or the 40s and stuff like that. And then what you have to do is kind of scroll through here and kind of try and match these lines. But the big things to look for is this NML line. That's new matched lines. So basically, if I go to this one here, that's a 38 peak, it's basically telling me that it's matching up 20 lines, and 8 of those are new matched lines, or new lines that weren't in the previous pattern. Now, what I want you to look at is that the crystal system is monoclinic. This is very typical. So when you start matching, monoclinic is such a very low, low, it's not like a cubic structure, right? It's very low symmetry. So you tend to have a lot of lines. So monoclinic is going to show up a lot as matching fairly well for these lines because they show up a lot of lines, not something that's going to be cubic where it shows up only a couple, or hexagonal or something. So just be careful when you're going through this that you don't see a really good match with this monoclinic. You want to make sure it's there. There's a lot of lines that aren't there. For example, there should be a very large line right this is why you want the object inspector up here, is there should be one at around 31 or so. And that should be like your major line. If you want to take a look to make sure, let's see. No, won't let me do that. But that's one of the things to take a look at. These little peaks that you see here. So these relative heights of these light blue lines, that's telling me that is the most intense peak there. And that's, again, why you want to do a really good background subtraction, because that's looking for the intensity there. Any questions on this so far? Okay. So, like I said, I kind of cheated on this one because this one is a standard. I'm now gonna load up something that's gonna have more than one phase in it. Okay, so we'll go ahead and we'll start a new window. File open, and again the raw data. Okay, so I know that this has more than one phase in it. So again, I have nice sharp peaks, and what I'll do is I'm just gonna go ahead and do my background subtraction. Let's go over here, and I'm gonna zoom up. One thing to notice on here, there's actually 2 things on here. So this one, if you notice, this is an automatic scale. So if I zoom up here, it's going to always set the scale to the highest peak position, okay? So if I wanted to take a look at the background of this entire area here, it's only gonna let me zoom up to as much as the highest peak. So you have to turn it off over here, okay? So I'm gonna zoom back out, and I'm going to come in and take a look at the background, okay? And again, I'm gonna do it manually, okay? So see how I said down here, it doesn't match really well? I'm gonna go ahead and I'm gonna add a point. And then I'm gonna move that down a little bit. This one down a little bit. Move that one down. See that. So this one pops up a little bit. I'm gonna move that one down here. Add another one right here. Okay, so I'm liking that, so I'm gonna accept that. Okay, so I'm gonna basically go through this one without smoothing it, and then we're gonna actually redo it, and you'll see the difference in the numbers after you smooth it. I'm gonna show, I wanna see, let's see. Show graphics. Well, it's not letting me see the graphics. Okay. So now we're going to go to search the peaks. Search peaks. Did a fairly good job. I'll hit accept. And now let's see the difference plot. Okay. So I'm going to go through. Okay, so it got a lot of these. There's a lot of the small peaks that really don't come up. So I'm going to go in and I'm going to go ahead and start adding some peaks here. So there's definitely one peak there. Maybe one small one there. Not sure about there. We'll see how that goes. Okay. Okay, so now I'm just going to go ahead and do a fitting. So I'm going to go to Analysis, Fitting, Start Fit, Default Profile Fit. Okay, so it got better. Got a 33. So let's see where it's. So now you can use this line over here to kind of see where the worst fits are. So if we zoom in on this area, that's not bad. Now, if I want to, I can actually move that peak a little bit because it looks like it's a little bit off. I can go to this little arrow thing here, and now all of a sudden, my peak has a position that I can change. Okay. And it also has a width. I can grab this and make it smaller or bigger. And what I'll do is I'm just going to make it a little bit bigger, move the position a little bit, and then I'm going to run that peak fitting again. Let's take a look at some of the other ones. Looks okay. See, something like this where it's very broad, there actually might be two peaks here. Okay. So what I'll do is I'm actually going to add another peak right next to it. I'll let that sort it out. Well, this one's way off. Okay, so same thing here. Now it says that there's a peak here, which I find very hard to believe. Let's go here. Yeah, I don't think that that's a peak there. So I'm going to come up here. Let's go to the peak list. So if I come to this one here, that's this peak 15. That's peak 15. So I'm going to go to peak 15. I'm going to right click and I'm going to delete that peak. Okay. Zoom out. Looks. There's probably a couple peaks there. All right. So let's see here. So there's a peak here. Yeah. I'll let that go there. There's a couple peaks here. And there's definitely one there. Okay. Okay, so we had a fitting of 33.6. So now I'm going to do the peak fit again. Okay, so it got a little bit better. And I'm going to just run it one more time. Let's go to... Yeah, so that's about as good as it's going to get. And I'm comfortable with that. All right. So next thing is I'm going to go right click and we're going to do a search match. Okay, so let's edit this again. So I want to clear everything. I'm just going to let it go through and look at everything. I'm going to keep it at the high quality. So typically what I'll do is the very first time around, I just want my high quality lines or patterns to match. If for some reason I don't come up with something, then I'll start to bring that down and say, okay, well, give me the blank ones as well and all that. But there should be enough patterns with these indexed and high quality ones that we can do. A lot of times I'll make sure if I'm getting way too many patterns, I'm going to skip all these non-ambient pressures and temperatures because I know that this one was done at room temperature, but we'll leave that for now. So now, again, I'm checking all the chemistry. So minimum number of elements, I'm just going to go to 1 because I really don't know, or usually I don't know. So I'm going to go ahead and search. Okay, and ioneodymium. I don't know why it keeps. I don't know why it keeps doing this. Still search. Oh, we'll hit OK. Okay. All right. So now here are my options here. Okay, and again, I want to look at my object inspector pane. Okay, so so this is the, again, match lines, 17 match lines. New match lines, well, everything's going to be new because we haven't matched anything else yet. And then total match lines. So it's basically telling me that of the 17 lines that are in this one file, all of them match. Okay, so that's usually a pretty good indication. I'm going to take a quick look at my information here. It's got a star quality, that's good. It's iron sulfide pyrite, which I'm pretty sure there's probably that in this sample. So that's actually pretty good. Notice that the stoichiometry is just a little bit different. It's 1.92. I'm going to go with this other iron sulfide here. Same thing. It's got 17 matches out of 17. It's a different crystal system. Let's see. It's been indexed. Okay. But it was marked as deleted by ICDD. So that's another thing I can do. Let's go back to my search match. So a lot of times if they delete the pattern, I don't want to look at it. So let's go ahead and edit. Quality. Skip marked as deleted. And hit close. So then I'll search again. Should give me the same. Okay, I'm not sure why it does this. It shouldn't put any patterns up here. Okay. All right, so again, we'll go through this list again. 1.92. If I go to the next one, it's different. Well, it's not that other one. So it's another star pattern. And the differences between the two is very slight. So if you look at the difference up here, 0.54, and that's this one here, delta D over D percent, minus 5.482. You can use that to kind of gauge yourself. So this one's actually got a very low delta. So this one seems to be matching a little bit better. And that's one way to take a look at this and say, okay, I like this one because it's got a very low delta here. It's matching 17 of the total lines that are in the pattern. So I'm going to drag this up. So now what you see is you've got your peaks identified for the iron sulfide. But if you see at the top here, you see all these little arrows and these lines. There's another phase in here, okay? So that's where you now have to start searching for that phase. So the next thing we're going to do is we're going to go through. So there's a lot of stuff in here. There's a lot of low quality stuff too. So I'm going to go back and I'm going to do my search. So now let's go back to restrictions, edit, chemistry. Make sure that these are all cleared. Minimum number of elements, 1, maximum number 4. Okay, I know a little bit about this. So I know that there's going to be some quartz in there. So I want at least silicon to be in here, okay? Minimum number of elements is 1. I'll say, okay, I still want high quality patterns, so close, and we'll search again. And one of the reasons I did that is we're getting all these other weird elements and chemistries here. Okay, so I don't know why it's automatically doing this. I'm wondering if someone came and changed some of the parameters here. But typically, again, you've got the silicon, and there's all these different types of quartz that you can look at here. One of the things I want to look at is this delta D to see how close of a match it is. So it's not always the top one, and it's not always the one with the best quality match here. Sometimes it's some of the ones down here. So you really have to kind of scroll through and take a look at the quality of the card as well. I mean, the sample color. They all seem to be doing pretty well. I have one here that's, you know, very close, very low delta. I mean, they're all going to be quartz pretty much. It's just going to be a slight change in the crystal structure. So I'm going to go with this one. It's got total lines, 17 are matching, and it's a new line. So NML is new matched lines. So basically, of the lines that are matching, there's 20. 17 are new ones. So if I drag this up, all right, so now that's my silicon, and then I've only got 3 other peaks that are not matched up. And I know that's probably something that's also minor in there. But for right now, that's pretty much my major constituents on here. So that's the way you do more than one phase. You find one phase that's dominant, then you find the second one that's basically the remainder. One of the things you can do too, when you're searching, say I want to see, I can arrange these by the ones that have the highest new matched lines, okay? So there's one that's got 23, obviously it's a different structure, but this silicon, but I can basically organize these anyway. I think the default is to go by the score, but you can go by any method here. I think there is also, yeah, you can do it by that way. Matched lines, new matched lines, total lines. Is this the displacement? Okay, so this one's the least amount, or that's the least amount, but again, some of these might actually work a little bit better. No, I would go new matched lines. Okay, so a lot of times I go by new matched lines if it doesn't automatically come up with the score. And that one's not even the one that I picked before, but it actually matches most of the lines. Okay, so now let's go back to, let's see. So see this difference plot? It's 32.57. I'm going to go back and redo this, and we're going to do this with a smooth so that you can see that the one big difference that you're going to see is just that you're going to be able to fit your pattern a little bit better with smooth data. So it really is not going to change anything. So we'll go ahead and add a new one. I'm going to load up the same file. Okay, so we'll do our, we can either do the smoothing before or after. I'm just going to do it before. We'll go ahead and smooth. And what that's going to do is it's going to put this other, the smooth pattern on top of the other one. It's hard to really see. I don't know why they choose those. It's not moving the peak positions, but you can see that it does adjust the height a little bit on these peaks, okay? And that's a smoothing of 3. Let's just try 2. That might be a little bit better. Let's just smooth 2. Actually, I know it's not going to hurt. Oh, let's do 3. So you can see the big difference. Okay, we're going to smooth by 3. Peak positions are not changing. We're going to replace. So basically, what we're going to do is just replace that smooth, the original data with the smooth data. You can see it's a little bit smoother down here now, less variability. We're going to go ahead and determine our background. This time, I'll actually do it automatically. Okay, so fairly high granularity. and a fairly low bending factor, in fact, 0. Okay, so I'll hit accept. And now we'll go ahead and search peaks. Okay, it did a fairly good job. There's some that it didn't pick up. So Control R, we'll add our peaks back in. One there. I think there's one there. Okay. Let's see our difference plot. Okay, so now we're going to zoom out again. And we're going to go ahead and do our peak fitting. So analysis, fitting. Oh, that's way off. Oh, did it do a peak somewhere over here? That's odd. Let's Control Z. I haven't seen that before. Let's see. I'm going to add a couple more peaks. There. And one right there. Okay. Fitting, start fit, default profile. Okay, so before the first one, after doing it several times, the value here was like 33. It's 18. So that smoothing helps a little bit. I'm going to run the peak fitting again just to make absolutely sure it's the best fit. Okay, so we've gotten it down to 16. So already it's fitting a lot better than before. But once we search our peaks, I'm sorry, when we do our, if you look at our peak list, it's going to be fairly the same. And if we do our search match, edit, let's get rid of the silicon. It should come up with the same results. And you have to be careful because since you guys are all sharing this, it seems to me like someone's already kind of like made some changes to the defaults because this shouldn't be doing this up here. It looks like it's automatically adding these into the, so be careful. Always check to make sure to view your object inspector pane, because a lot of times when you look at these cards, they'll have something very odd on here, or they could have something odd, okay? So it could be something where it's taken at high temperature or high pressure. That's why I usually filter those out, because I know that my material was processed or is at room temperature. Okay, but then once everything's on there, just go ahead and drag them up, and then that basically identifies them. Okay, and go by all these different values here: the matched lines, new matched lines, total lines in the pattern. Those are typically the things that I go through. Just be careful with monoclinic phase. If you're looking, if you've got kind of an unknown phase, or if and you start to pick up a lot of monoclinic structures that are matching well, you may have that monoclinic structure, but realize that monoclinic structures tend to have so many lines that they will match a lot of the lines in your patterns. Okay.